Hello, this is Scholar Shaft doing some math today in Algebra 2. We're going to look at the general angles and use some radian measure here. So a standard position of an angle is an angle whose vertex is at the origin and whose initial side is on the positive x-axis and opens counterclockwise. So here, let's add some color to this. That red line would be the terminal side of your angle. Vertex is at the origin. And then we have a initial side lying on the x-axis here. So here's another one, initial side, and terminal. All right. Draw an angle with a given angle measure in standard position. So first off, we need to find out what 405 degrees is. A full circle is 360. So we want to know how much a little bit above 360 that is, and that's 45 degrees. So a 45 degree angle, it looks like that. Like that here. And what's going on is we have that's how we would draw a 405 degree angle. So we always measure clockwise or counterclockwise unless we go negative. If we go negative, then we're going to go down like this. So this would be 75 degrees. A coterminal angle is an angle whose initial and terminal sides coincide but have different angle measures. Like example 1. 405 degrees is the same as 45 degrees. End up in the same spot. Find one positive and one negative angle coterminal to 150 degrees. So if we don't know what 150 degrees looks like, so this would be 90 degrees, and then a little bit more for 150. So 150 here, we could take 360 and add 150, and that would give us 410 degrees, or 510 degrees. So 510 degrees would be one positive angle, and how that would look like, let's make this red, or actually it would look like this. Something like that. And then to find the negative coterminal angle, all you do is take 360 minus 150. And that'll give us 210, and then we just make it negative. So this one will be the blue. And I'll just put it on the original picture here. The blue angle would look like that. A radian is the measure of an angle in standard position whose terminal side intercepts an arc of length S, where R is the radius of the circle. So 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length S. So here is S. There's the radius, and there's 1 radian. So the radian formula is theta is S divided by R. If we want to convert between degrees and radians, we take our degrees and we multiply it by pi radians over 180. And if we want to go backwards, we take our radians, multiply it by 180, and divide by pi to get degrees. So let's do some examples. So if we want 75 degrees and we want to transform it into radians, take 75 times pi divided by 180. And that would be 75 divided by 180, that reduces to 5 over 12, and then pi. No more degrees. These degrees cancel. Part B, this is in radians, so we're going to switch it over to degrees. We take a negative 5 pi over 4, multiply it by 180 degrees over pi. The pi's cancel, and we're left with negative 900 degrees over 4, which is negative 225. Circle in degrees and radians. Memorizing the degree and radians measures of a circle helps us build the unit circle with cosine and sine values for each common angles. So if we remember this as 0 or 0 degrees or 0 radians or 360 degrees if you go full circle, or 2 pi. At 90 degrees, we call it pi over 2. 180 degrees is pi. And at 270 degrees, we call this 3 pi over 2. 45 degrees is pi over 4. Uh, 60 degrees is pi over 6, or pi over 3, I mean. 30 degrees is pi over 6. And if you want to find the rest, so for example, 30 degrees, if you wanted 120 degrees, you can count by pi's over 6. So for example, 2 pi over 6 is 60 degrees. 3 pi over 6 is 90 degrees. 4 pi over 6, or 2 pi over 3, is 120 degrees. And you can look at the chart on my on the modules if you wanted to see the rest. So for an angle measured in radians, the arc length formula, so arc length S equals R times theta. Area is 1/2 radius squared times theta. Cheese. A circular piece of cheese has a portion cut out as shown. What is the approximate arc length of the portion that is missing? So S equals R theta. So S equals 2 times pi time over 4, which is 2 pi over 4 or pi over 2 inches. Because they tell us the radius is 2 and the angle in radians is that. Part B, what is the approximate area? So area is 1/2 2 squared times theta. So I'll get 2 squared, which is 4, half of that is 2. I will still get pi over 2 square inches. At an amusement park, you ride a swing that takes you several revolutions counterclockwise, as shown in the diagram. Find the measure of the angle generated as you are on the ride. Give the answer in both degrees and radians. Okay, so we start here, and then we go 1 circle, 2 circles, 1 circle, 2 circle, 3 circle, 4 circle, 5 circles, 6 circles. Let me see. 6 times 360. Oh, almost 6 circles. Almost full 6 circles. So 5 times 360 is 1800. And then on the last path, we go all the way to here. So remember, this is 270. So this is 230. So 1800 plus 230 is 2030 degrees. So once again, I found this 1800 because he went around the circle 5 times. And then he didn't go a full 6th circle, but he went 230 degrees. So 2030 degrees, and then we're going to convert it to radians by multiplying by pi over 180, which is 2030 pi over 180, which reduces to 203 over 18 pi radians. Hopefully this helped you out. Have a good day.